As we can see here, the SW1 switch reference, the encoder that we're trying to source here, was actually made by Wavetek for this Wavetek 288 model. You can see that they made it from a prior encoder that they had, so maybe they changed that PCB board on the bottom or an optic inside. Not really sure, because the one I had was completely broken into several bits. This reference code means nothing. Wavetek is no longer in business, and there's no one to pick up the phone or email and try to get any information. Unless somebody out there knows something more, they can let me know. I cannot seem to locate anything from Born as a cross-reference when I reached out to Born specifically. So now it's into a area of, feeling out how we can find an encoder that's going to work with this particular unit. So the original encoder rather, is the ECW0J-B24-SE0005. No longer made by Born. And they have no paperwork on that unit, as they have gone to a different format for all their encoders. I'm sure there's something modern that we can figure out. So what I've done is I have ordered another unit off of eBay, of all places. And same place I got the first one, making a joke. At any rate, so let's find out whether or not this one is going to be workable. I hope it is, for the little bit of money I did spend on it. So I'm basically using this as a parts unit. Oh, that's an interesting sign. That's one of the feet from the bottom. Hopefully this is packed well by the company that sold it to me. Again, there's a lot of these on sale on eBay. Some in different stages of repair than others. This one is pretty battered and tarred from what I could see in the photos. Yeah. But what I'm hoping... okay, so we can see that this is a detented encoder. So I'm hoping that this puppy's good. Because if it is, and we can test it, then I can cross-reference it with a brand new encoder that will work and give us the same functionality in a modern equivalent. So there's some... Oh, boy. We can see this has got some issues, right? Lucky I didn't pay a lot for it. So I guess I'll spare... Well, no, let's open it together. I was going to say I would spare you the screwdriver here. Let's see what it looks like. Let's find this out together. I was going to spare you, but there's only a couple of screws here. So just like my other one, somebody has been inside before me. Man, this is tattered a lot. Whereas the other one I have is mint in comparison to this one. At least from the outside. It's got a big dent right here. If I remember right. Yeah. Oh, no screw missing. Oh, no screw from here. So it looks like somebody's been inside again before me. Oh boy. Wow. Wow. That that bend in that metal sure makes this a hard one to come off. Man, oh man. Well, screw it. There we go. Well, at least I have a parts unit now. Oh no, it looks like all the cards are there. Fine. And any luck, that encoder... Yes, can you see in there? Let's zoom in. Looks like it's factory. Oh, you probably can't see that yet. All right, let me get this face off, and then we'll be back at the next shot. You know what I thought? Just for the heck of it, let's power it up and see what it does. If it does anything. Taking a chance here because this guy is in pretty bad shape. Oh, okay. That's a good sign. Let's go to calibrate. Well, it's doing the very same thing. Let's see you in 20 minutes. Wow. Look at that. This thing has got hot at some point, huh? My goodness. I don't see any burns or anything down here. But it sure is in a precarious state with this part of the chassis being broken here. You can slide that back into the shot if you can see. See that part of the chassis there is totally broken. And not so good. Well, I should turn some light on here, huh? There, now you guys can see a little bit better. Yeah. All right. Looks like it's still counting down, 19 minutes. See you then. Concerning replacing the battery, it's done right here. And it is a DL2430. That's for Duracell, or CR2430 if it's going to be for Energizer or another brand. So nonetheless, 2430 is what you're after. You need to change that battery with the power on. That way you're ensuring, the manual also states that way you're ensuring that you don't lose the information on that RAM chip. But again, be very careful when you're sticking your hands inside of here that you don't come across the voltage lines and hurt yourself. Use a plastic tool when replacing that battery. What I like to do is I like to put the plastic tool underneath, lift up the clip, start pulling one battery out with, say, a pair of plastic tweezers so you don't damage anything. Start sliding the other one back in. So this clip never bottoms out on the negative plate on the bottom, just as a precaution. And another thing here, oh, look at that. Didn't see that before. If you can see that, let's zoom in on here. Me and the shaky camera, got to fix this thing. It says there, replace battery at each maintenance interval with power on. See maintenance manual for details. All right, well, we just covered that. So that's where the battery's at. Make sure the power's on when you replace it, and be careful. Well, look at that. She calibrated. That's a good sign. So I guess now, I mean, we do the calibration again. You guys seen it on video. One pulls the information from a RAM chip that's already stored on the motherboard and applies calibration settings to the unit. And if it auto calibrates, that means there's just enough power in that battery. There it is. Good to go. See that? There's just enough power here in this 3-volt battery. You can see it. It's charging at the moment. You can see that LED flashing. There's just enough power in that 3-volt battery to keep that RAM chip alive. So that's, if that battery was fully dead and the information was gone from that RAM chip, for instance, if you pulled that battery with the power being off, you would probably lose that information in that RAM. So if you have one of these and you're going to work on this, again, you're doing so at your own endangerment. For the voltages that are put inside here, through these caps and so forth for the power supply and in different areas, you can hurt yourself. So be careful, educate yourself before you start tinkering around with electronics. At any rate, if you were to pull that battery with the power being turned off, you run the risk of losing the pre-calibrated specifications that are stored on that RAM chip for this unit by the factory. So fortunately, that hasn't been done yet. So even though I'm probably going to use this for a parts unit, I don't imagine that I'll do a full restoration on this one. She's kind of beat up. But we'll see. Otherwise, I'll part it out, and if anybody out there needs parts for one of these guys, you can shoot me an email, and we can go from there. There's various things in here, especially a lot of these chips. Some of these chips aren't made anymore. Some of them are from Brazil, again, aren't made anymore. Easy pulls. Some of them are socketed. So those chips could be useful. Lots of useful parts in this application. At any rate, moving on, I am going to now test this encoder. All right, let me flip this puppy up, and I'm going to do it generically here. But hopefully, here's the big moment, and the knob is enabled here. So if this moves, oh, look at that. Okay, so we have a workable encoder. Wonderful. So this one, I want to go too fast or put too much pressure on it, but yeah, she seems to be working just fine. So now we have something that we can diagnose, and I can match what that encoder is doing to be able to be utilized in this circuit, and hopefully source a modern encoder for replacement. So hopefully you can see this here, but this one is also slightly different, but the same. Let's see if I can get the camera to focus on this guy here. Right, ECW 0J-Z24-SE0005. And if we again look at the modern offerings from Bourne's, we can see here that there is no E0005 at all. And of course, there's no Z as well, but that's regardless. 24 is just the shaft length. So I thought what we'd do here is set up a little test fixture so we can look at what the encoder is actually doing in the circuit. I've just taken my digital multimeter and put the positive lead on the center wiper of the encoder, and we'll test the two outsides in each detemp position to see what's happening. So I'll just take the DDM, put it on ohms, and in the first position, nothing on the right and nothing on the left. So the way I'll demonstrate this is basically how the industry does it, but at any rate, so we'll say this top line here is a closed value. This bottom is an open value. Top, closed, bottom, open. So if in this first position I have open and open, that's going to mean that that's open here and open here. So I'll choose this line right here. We'll call that detemp position number 1. So if I turn this one notch to the right and I measure the left side, she's closed, and the right side open. So I guess we'll choose the, let's see, if this is open, open, what did I say? We'll choose the left side is closed and the right side is open. So I guess the left side here would be closed, the right would be open. I guess that's the next line right here. So that's 2, so that would make this one the left side and this one the right side. All right, let's go on next one. So next movement over to the right, closed, closed. Great. Okay, so we can see a little pattern here happening. So closed and closed. As you can see, closed, closed. That's detent number 3. Detent number 4. Closed on the left. I'm sorry, what was that? This was open on the left, closed on the right. So closed on the right, open on the left. That's this one. And we'll go to number 5. Open on the left, open on the right, open, open. So that's one way of doing it, and you'll see that on that Bourne's data sheet as well, in a way to decipher what's happening with this encoder. So another way to do it is just kind of sort of my way. May not necessarily be the right way, but what we'll do is we'll just call this center an already known value. And if we call this position number 1, we know that it's open and open, denoted by our last test, right? Open, open, great. So if we go to detent number 2, closed on the left, open on the right. Closed on the left, open on the right. That's detent number 2. We go to number 3, close on the left, close on the right. Detent number 4, open on the left, close on the right. Detent number 5, open, open. So if this is a pattern, which it should be, we should see that number 6, if we continue in that fashion, because there's 36 detents on this particular encoder. I put a little pencil mark on the top of the graphite shaft there, and I counted carefully, excuse me, as the detents went around, and took a note that there are 36 detents. So that's a feature that we'll look for in this encoder when trying to source one. So 6 should theoretically be in the same as 2. So let's see, did I do that yet? That's open. That's open. So we're at position number 5. So let's go to position number 6. Yeah, close on the left, open on the right. So position number 7 presumably will be close on the left, close on the right. Yes. So we can start to see this pattern. So 8 should theoretically be open on the left, should be closed on the right. And it is. So there it is. And for the sake of brevity, we'll go to 9. Should be open. And open. Okay, so we can see that we could say the true value of this is in 4 detents. We get all the position that all the functions that this particular encoder is set up to do. 2 values of open, left and right. 1 value of closed on the left, open right. 2 closed, 1 right, close for number 4. And that continues to repeat. So if that is done all the way through for 36 times, then if we have another encoder that does the exact same action, then we know that that encoder will work in this particular circuit. So here we see that we have same kind of setup. This is the one that I sourced. So on the left I have open, on the right I have open. So we'll just say check. We'll go to the second position. On the left, she's closed. On the right, she's open. Another check. Third position, left closed, right closed. Check. Fourth position, left open, right closed. And of course, fifth position should be left open, right open. Winner, winner, chicken dinner, yay. So if you're going to source one of these for your Wavetek 288 signal generator, this is the one that you need to source. ECW0J-B24-BD0009L-ND. And that will get you up and running. And the great thing is you need to try to order this particular one if you can. Now, I'm not affiliated, but I think both Mauser and Digitech has this guy. Be sure that the one you're ordering has the PC mount bracket, because they also sell them without the bracket. And this particular one that I got from Digitech also has the 3 leads on it. So if we look at this guy, this is the one that I purchased from Digitech. Let's see if we can get the camera to... So that's the numbers. If you can read that off of there, I'm not sure if the camera's focusing or not. I don't have a reference. But that's the one that is this one that's going to work as a replacement. So let's get this installed and see if the project's going to work. So one quick note here I wanted to point out that if we see this particular one, D0009, there are 36 detenths and 9 cycles or revolutions. So of course we took note that we had 1 revolution as 4 encoder positions. 4 times 9, 36. Just before I go about installing this one, I thought I would show you guys, not sure if you can tell or not, but there is 1 trace, the center trace is on this side of the board. If we flip this puppy over, you can clearly see the other 2 traces, the left and right traces, are on the opposite side of the board. So let's be careful now, if you guys are following along, and making sure that you clean those holes out, those vias out correctly, and get a clean install and solder both sides. At least that's how they had it at the factory. I'm going to do the same here. So one thing you guys are going to have to do if you care about the aesthetics or that knob sticking out so far from the unit is you can see that the one that I ordered here is a little bit longer. It actually comes in at 3/4 of an inch. Here, this one. The factory one is cut at 5/8. So that's so this little bushing can go on, and then you can put the knob on. So you have to take 1/8 inch off of this one if you want it to be just like the factory. I think I'll do that. Just lightly take it with a hacksaw. In fact, I don't think you guys can see here, but it looks like, let me get a light on this. It looks like they did that actually at the factory themselves. So I wonder if that is what part of the modification, them saying it's a Wavetek product, clearly made by Borns. Nonetheless, I'll cut that off and get this thing installed. So now that we have the encoder, we can take this guy, and once the vias are cleaned out, when you place it inside, it should be nice and clean. Shouldn't have to force it in any way, form, or fashion. And make certain that it is fully seated all the way onto the circuit board. So what I like to do typically is what I'll do is I'll just drop a little solder on one side here. Get a little flux on there. Then I'll hold the encoder and put just a light amount of pressure on the body, not on the knob at all, because they're very delicate. So I'm just holding the body, those 2 fingers right behind where I just soldered, and I'll reflow these and heat them up. And if they're going to push in, they push in. So now I've got just a very light amount of pressure there, solid. So now I know that this thing's not going to move, and when it's actuated, it won't have any problems in the future, like falling apart, because it has support right from that bracket directly. So good to go there. You want to be very careful when doing these ones. I typically like to do the center first. Let it fully cool. Do one side. Fully cool. Other side. And not too much solder, but just enough. So now, you want to be sure that the solder flowed to the other side. If you don't see it, what you can do is you can add a little bit more to the top side here. And again, it's something I noted that they did from the factory, but you've got a pretty sharp solder point to do so. This tip is a little bit dull. She's been around. That one flowed pretty good. Both of those flowed pretty good. These two, I guess I didn't have enough on there. A little solder ball. So now you can't really see, but all right, the solder flowed all the way through on those to the other side as well. So that's very, very well done. So that's installed, good to go. In case any of you forgot the order of how this goes back together, so you have this cowl that goes on here, small tension cowl. You can take, once you cut this, if you need to, if you get a model that you have to cut, you can always take just a fine file and very delicately round off the edges if you cut it with a hacksaw, because it is just a graphite shaft, but be super careful. It's pretty delicate. So that guy goes on there, and then followed by the knob itself, then followed by the washer, followed by the nut, and finally the cap. So you can hold the knob, put a little tiny bit of in pressure on there, and just hand tighten this guy. I wouldn't even use a tool on that. You can if you need to, depends on how strong your fingers are, but I just hand tighten it, call it a day. It's not coming off there, not going anywhere. Doesn't need a lot of pressure. But if you're more comfortable, you can give it a little bit with a tool. Then you can see there's these two knobs here, these two notches here. Just make sure, it doesn't really matter where you have that. As long as it's lined up, you can kind of feel where it needs to go, and it should just snap on like so. Pretty easy. Done. So one thing to think about when you're putting this puppy back together for yourself is be very careful how you position those cards in their slots. It's easy to get them. They actually go in these guides in between, not the large spaces, but the small spaces. And be certain that you get them in obviously the correct order. So a couple things that have to happen here is this connector has to go back on, and then this ground has to be reseated to this pin right here, so you can see. And make sure that that's pushed on there nice and has some rigidity to its connection. Good to go. Also be sure that when you push this back together, that this guy right here is seated and seated well before you put the 4 screws back on. And be certain as well that as you're putting this case back together, the PC board on both sides, actually you can see the slot here. It actually slides into this bottom rail on both of these extrusions. So be certain that's the case, because if you try to force this closed, you're going to end up snapping that fiberglass circuit board, and then it's game over, right? So you have some trouble from there. So let's start with this back shield. So the back shield has 2 screws on the top, 3 screws on the bottom. The screws go this direction, and they go in these slots here, right here on both sides. So again, be careful as you're placing this in that you go straight down. And there's 3 screws that go on the bottom. So what I'll do is just flip this over, put it on its side, and then out of these 3 screws, there should be 3 that don't look like the other 3. All right, well, I'll get that sorted, and then I'll put those in a little bit later. I can't decipher which ones they are. Now I got to go through them, because there's 2 up here that I think are slightly different than the 3 that are down here, but I'm not sure of that yet. We'll get back to that. So the next card is going to be this card. Goes in this orientation, and you can see these female pins will meet up with these male pins down here in those two connectors. And again, be very accurate when you're placing this in, that you're inside the small slots and not the large ones. So you got to kind of eye it straight from the top and feel your way as you're going to be certain you're on the right one. There, that looks good. And then once you think you got them in there, make sure that these tabs right here on the sides go in. Let's see if I can show you this view here. That they go into that second rail. So watch what happens here. Straight up, down into that second rail. See this second rail here? 1, 2. And they're both connecting. So then by the time you push them down, the board will seat correctly. So I do this a little differently. You can choose. Some people just plant them home. But these pins are a little bit inset. So I put a little pressure on the top of the board slightly, and then all at the same time. And then if you really want to be sure, you can just kind of move it left to right slightly. Make sure that you don't feel any movement in there. And then again, re-examine that you are correctly in the slots. And as you can see here, let's get a close up. You can see that I'm right in that thin slot there. Both sides, right? Okay. So now, oh, look at this. October 4th, 1990. Cool. So now we're going to put the next item in, and that's going to be this shield. It's going to go on the front side of the board. And again, going into those thin slots on both sides, this black protector will be up. This folded edge will be down. The next set of rails over is where this goes. And once you're there, you should see that it's slotted for these 3 ground connects here. And then you can just push on the top gently. Make sure that it's seated on both sides, that you can physically see. See down in there. Good to go. All right, the next board, or card as we could say, or daughter board, will be this one, facing toward me. And again, looking for those proper alignments in those slots. There we go. Seeking that second rail. These are straight up and down. Seeking that second rail below. And good to go. Check. Next item is this next shield. Same thing. Ridge, folded ridge to the bottom, protector at the top. Good to go. And the final card has its own shield on the front. So you just got to be careful that that also gets seated. So you can see down here the ground connections for it here for the shielding. So this will be the most precarious one to put in. You got to be real careful here that you're hitting all the slots. And you want to check down inside to be sure. Yep, good to go. Good to go. These are straight up and down. Gently, gently, gently. Finding that second rail. And should be seated. Give a little rock back and forth, left to right, slightly. Just to be sure. Feels solid to me. Alright, so at this point, still got to put the 3 screws in on the bottom here. And 2 screws up on the top here, 2 screws up on the top here. So we have this shield that will also go here. But before I put that shield on, actually I guess I could do that now. Shouldn't hurt anything with the bottom one. So I'll put all these screws in the bottom 3, the ones in the top, and then we'll be right back. So as you can see here, I actually forgot that this shield here just lays on here until you put the top on. So that's the correct order. And prior to that, before I placed that on, I did locate the other 3 screws that are slightly different, slightly shorter than the case screws. These 3 right here, and put those in. They had a little bit of Loctite substance on there. I chose not to put that back in in case this isn't going to work out. In case this unit fails and blows up on me, which is likely. So let's go for this. And this slides in this direction. And carefully seats all the way. Great. I'll get these screws in here. I'll be right. There's 4 screws for the top. 1, 2, 3, 4. Be right back. So the bottom does the same thing. There's only 1 screw in the center. So we're gonna slide her here, left and right. Careful of that, if you've seen that or not. There we go. Good to go. So 1 screw here. And there's a pop. So you hear that pop, that's this particular tool here called a YHA. And it has an increment range of PSI that you can put on there. So this particular case, for most of these, I'll put it at 5 pounds. Most computer cases, metal cases that have screws, 5 pounds is more than enough. You can set it for more if you want to, but it makes it easy so you don't over tighten the screws. So for instance, I've got these 2 here. I'll zoom out a little bit. Not that you guys want to watch me putting screws in. But with this guy here, you can listen for that pop, and that means that when it stops and has that little pop, that it is at 5 psi. So same thing here. There it is, done. The moment has arrived. It is auto calibrated, so that makes me happy. Auto calibrates automatically, obviously, once you hit calibrate. Waits the entire 20 minutes and goes through it. Let's see if it works. Here we go. Who's going to bet that it doesn't? That'd be my luck. All right, let's go to frequency. Oh, that's a good sign. I don't know that we had a flashing anything before. It's enabled. It's unable. Shouldn't work. Okay, enable. Here we go. Ah, yes. Great. Super easy. Done and done. Let's give her some go. Yeah. All right, forward and backward. Wonderful, wonderful, wonderful. Let's change the range here. Yep, beautiful. Nice and easy. That detent feels great. And she appears to be doing her job. 3, 2, 1, 0. Nice, easy. 7, 6, 5, 4, 3, 2, 1. Yeah, she's good to go. So happy with that. So the next video will be showcasing what this unit can do. It's not as complicated of a signal generator or function generator, actually, if we want to get down to it. It says signal generator here, function generator there, but it's actually a function generator. Slightly different than a signal generator in a sense. So I'll explain all of that in the next video, showcasing what this thing can do. All right. Thanks so much for watching.